Okay, good morning. Hello everyone. So welcome to Statics of Rigid Bodies at 3-unit course, no? With subject number CE231. I am your instructor and I am Engineer Joselito Ontal Ferraren. Our grading system is like this, no? But we will be talking more on this in our Zoom meeting na lang, na? So we have a passing mark of 60 for midterm and we have items to consider to arrive with that whatever, no? Midterm performance we have, no? Then we also have by final, you will be graded also in final, no? With the same, no? So our passing mark is 60. So we have items to consider and we will be discussing more on this in our Zoom meeting para you can interact. Okay? Then for the introduction of the course, no? So we have the term mechanics, no? So mechanics is actually a science that deals on the condition of bodies in rest. This is actually a branch in physics, no? So bodies in rest, so we term that as statics, and the bodies in motion, we term that as dynamics under the action of forces. So two areas are field and mechanics, no? Wherein physicists and astronomers, no, or even electrical engineers are focusing on this, no, in the study of field of particle mechanics, celestial mechanics, quantum mechanics, and the relativistic mechanics. For us, engineers on, so we will be focusing also in the field of engineering mechanics. Okay? So what is engineering mechanics? So this is just an application of the principle of mechanics and problems commonly met now within the engineering practice, no, like design a building, bridges, machines, etc. So this is the diagram which will show the different branches of physics and mechanics. So physics, so we have three branches, and one of which is the mechanics, thermodynamics, and electricity. Now, in engineering mechanics, so we also have branches. Actually, we have two branches. So we have the mechanics of fluids and the mechanics of solids. Now, in the mechanics of solids, so we have rigid bodies and the deformable bodies. Now, so statics actually comes out as a branch of mechanics of rigid bodies. So statics as a branch. Then we also have dynamics, and dynamics also have branches like kinematics and the kinetics. Now, so for deformable bodies, we have theory of structure, theory of elasticity, theory of plasticity, and the strength of materials. Okay? Then for fluids, so we have three branches. We have ideal fluid, viscous fluid, and compressible fluid. Now, mechanics of rigid bodies. Rigid bodies are those bodies assumed to resist any form of deformation. So when they are acted upon with forces or a system of forces, the bodies is assumed not to experience any form of deformation. So the engineering mechanics, the mechanics of rigid bodies, as we see in the diagram, actually it has two areas. Again, we have statics that deals on bodies and or equilibrium of the bodies, that is either at rest or they are moving with constant velocity. The other one is dynamics, and this is good for bodies that is having an accelerated motion. Okay? So we have fundamental concepts. Now we will be dealing on common quantities, no? So like quantities like length, no? And it is defined as this. So it is used to locate the position of point in space and thereby describe the size of a physical system. Once a standard unit of length is defined, one can then use it to define distances, geometric properties of a body as multiples of this unit. Then we also have a unit of time. Actually, dili kasi importante here in statics, no? Time is conceived as a succession of events, although the principle of statics are time independent. But this is a quantity playing importance in the role, having an important role in the study of dynamics. Then we also have the term mass. Okay, so mass, a measure of the quantity of matter that is used to compare the action of one body with another. This property manifests itself as a gravitational attraction between two bodies and therefore and provide a measure of the resistance of matter to change in velocity. And last is the force. In general, force is considered as a force or a pull exerted by one body to another. This interaction can occur when they are having a direct contact, now such as a person pushing a wall, or it can occur through a distance when bodies are physically separated, now like gravitational force, now. So in any case, a force is completely characterized by its magnitude, direction, sense, and point of application as the characteristics of the force. Okay? Then, system of units for this quantity. We are actually having the SI and the English unit here. So for the unit of length in SI, we have meters. For English, we have a unit in foot or inches. Then, for mass, we have kilograms. Slugs for English, no? For this is for SI, kilograms, no? Slugs is actually a unit same as this, no? Slugs or pound per second squared per foot, no? So this is actually 1 slug. And for a unit of time, for SI we have seconds. For English we have seconds we have one. No, okay, but we have seconds both for English and SI, no? And for a unit of force, we have Newton for SI and pounds, no? So we have this abbreviated as this, no? Or kips. This is actually kilopounds, or 1,000 pounds is good as 1 kip, okay? And 1 Newton is also defined as 1 kilogram meter per second squared. So we have prefixes used, no? If we have 10 to power 9, okay, how many zeros from 1? Okay, so we have 9 zeros, no? Okay, so we have, actually, the prefix used is giga, and the symbol used is capital G. Then this is 10 to power 6. Okay, so we have 6 zeros after 1. Now then, that is good as mega. So using a capital M for mega symbol, no? Then 1,000, that's kilo. So you'll be using a small k, no? Then sub-multiple, 0.001 or 10 to power minus 3. That is read as milli, as prefix, no? Millimeter, no? So what is the symbol used? M. So if you have meter, maduble, millimeter, mm. You can see it as mm, no? But milli itself is m, small m. Okay? Then we have 10 to power negative 6. If you observe, if you have 1 here, so we have how many zeros before 1? Okay, so we have an after the decimal point, no? So 1, 2, 3, 4, 5. So 10 to power minus 6. That is read as micro. Okay, the symbol is here, mu, no? Then this is 10 to power minus 9, no? So how many zeros? So we have 8, no? Then that is nano. And that is denoted with small n, no? Okay, so those are the different units used and the quantities, no? We can commonly encounter, and the prefixes, no? Prefixes, no? So we have also prefixes and symbols, okay? Then for conversion, we have some direct conversion, like 1 foot is good as 12 inches. 5,000 to 80 feet is good as 1 mile. 1,000 pounds is 1 kip, because that is good as 1 kilo pounds as you read, no? You can also read it as kip being kilo pounds. 2,000 pounds is good as 110. Okay, so we have table of values. First, 1 pound, that is 4.448 in Newton. Slug to kilogram. Foot to meters. Okay? Then we have different axiom. Okay, so first, parallelogram law must be observed. The resultant of two forces is the diagonal and the vectors of these forces. No? A force is a vector quantity. So once you have to graph them, no, or show the graphical representation of the system, so if your system is composed of two forces, no, then the diagonal of which will serve as the resultant. Two forces are in equilibrium only when they are equal in magnitude, opposite in direction, and on the same line of action. Third, the set of forces in equilibrium may be added or subtracted to any system of forces without changing the effect of the original system. And last, action and reaction forces are equal and oppositely directed. So we are also governed with the Newton's three laws of motion. Engineering mechanics is formulated on basis of Newton's three laws of motion, the validity of which is based on experimental observation. These laws apply to the motion of particle as measured from non-accelerating reference frame. They may be briefly stated as follows. We have first law. So particle originally at rest or moving in a constant moving in a straight line with constant velocity tends to remain in the state provided the body is not subjected to unbalanced force. No? So, if originally mo na yung forces, no? Once this is not acted by an unbalanced force, so the state of this body remains the same. The second law is a particle that is accelerated. No? So, a particle acted upon by unbalanced force experiences an acceleration A that has the same direction as the force and the magnitude that is directly proportional to the force. If F is applied to a particle of mass m, this law may be expressed mathematically as force being a product of mass and acceleration. If the force is acting on the body, on that direction, then the body will also be accelerated on the same direction as the unbalanced force or the force that is acting on the mass m. Okay? Third is this is the action and reaction, no? So, the mutual forces of action and reaction between two bodies are equal, opposite, and collinear in action. So, see, if you have two bodies, A and B, so if the force here in A, no? So, and this is B, so these two forces must have the same magnitude, opposite in direction, and on the same line of action. Those are the three laws of motion. Okay, so, for next topic, no? So, just try to wait for the next video. So, thank you for watching and have a good day. Bye-bye.